Alright, so I promised today's lesson on simple trinomials, day 2, will be actually a lot faster than day 1. Again, if you feel like I'm going too fast, you may want to rewatch the first video on simple trinomials or pause and rewind this one as we go. So I want to start off by saying just consider FOIL. So again, that factoring is basically the opposite of distributive property. We kind of have to start off with a distributive property or a FOIL question. So you'll remember that with our first example here, x plus 2 multiplied by x minus 3, we would do FOIL. So first would get us x squared, outside would get us minus 3x, inside would get us positive 2x, and outside would get us positive 2 times negative 3, which is minus 6. And that x minus 3x plus 2x simplifies to be negative x minus 6. Okay, so you'll notice that contrary to yesterday, this last term is now negative. All right, so yesterday's term, they were kind of all rigged so that this last term would wind up being positive. This last negative term actually gives us a bit of a hint about the nature of the two numbers on the inside. But doing the second example might reveal that. Okay. X multiplied by x is x squared. X multiplied by positive 3 is going to be plus 3x. Negative 2 multiplied by x is going to be minus 2x. And negative 2 multiplied by positive 3 is going to be, again, the negative 6. That simplifies to be x squared plus 1x minus 6. So you can see that that last term again is also a negative. So what these two negatives do suggest about the numbers that are inside is that the signs were different. So if we take a look at a few of these examples, the first one being x squared plus 7x minus 18, we're going to ask ourselves the exact same questions as we did yesterday, only the answers to those questions are a little bit more complex. So we're looking for the numbers that add to 7 but multiply to negative 18. Remember that if they multiply to negative 18, their signs are different. So that means we're looking for two numbers that add to 17 and multiply to negative 18. So we even have a few more hints actually this time. Right? We're going to start off with an x. We're going to start off with an x because we had x squared as our first term. One of them is going to be a minus and one of them is going to be a plus. Now, we've had enough time to sort of think about it. 18 and 7 would be 9 and 2 because positive 9 and negative 2 actually do have a sum of positive 7. So the sum number, the add number, is not going to be as clear. So I'm going to pause it and actually change my margins a little bit, but you can see all three of those problems. Go ahead and give them a try. And so you can now clearly see all three of these answers. You can tell that the two numbers here were negative 6 and positive 2. Again, we were looking for a adds to negative 4 and a multiplies to negative 12. Those two numbers would have different signs. One was a negative and one was a positive. And the negative one was the larger number because the adds to, or the sum number, was negative. Okay, so the same thing happens with question C and with D. With question C, we know we have a negative sum, so the negative number has to be the larger, and we're again looking for a product of negative 27. So it has to add to negative 6 and multiply to negative 27. So again, those are our two numbers. With question D, a little bit of the opposite happens here. You can see that the sum was a positive number, so our adds to was a positive 8. That just means that the positive number was the larger one, as you can see with positive 10 there. So here are 6 more examples. You'll remember these are actually almost identical to what we saw in yesterday's video. So with questions E through H, all of these ones seem to have this mysterious last term at the end of them. Okay, so don't forget that those terms actually wind up being attached to the last set of the last terms in the binomials. Okay, so y, q, b, and d respectively. With I and j, don't forget to common factor first. Okay, we have this awkward number 2 in front and this awkward number negative 3 in front. We have to factor that out. We have to common factor it first. So with those hints in mind, I want you to go ahead and try all 6 of these problems. Pause your video, and the answers will appear. Okay, so you can see your answers here for E, F, G, H, and I and J are a little bit obscured, but we'll go through them really quickly. You can see in red my adds to, my multiplies to question. Okay, so I'm looking for things that add to those numbers and multiply to those numbers. You'll notice again that that y tags along because my last term multiplied by my last term has to be y squared. It has to be something y squared. Right? The positive 5 multiplied by the negative 4 yielded negative 20y squared. So that's where those terms wind up having those variables on at the end of them. So questions I and J, a little bit more complex. As you can see, I had to do common factoring first. Yes, there is a method that I'm going to cover when we start talking about complex trinomials that we deal with it. But your first point of call is always to common factor that coefficient out. Okay, so that leak coefficient needs to be common factored out, and you're going to actually, it appears in your answer as well. Okay, so a typical error is that it just magically disappears. It doesn't. 2 is still out in the front of it, and it's still being multiplied by the result of that trinomial factoring. Okay, so hopefully this lesson was useful. Hopefully it was quick enough for you. Watch it, rewatch it, make sure you make some sense of it, and we'll see you in class.